The image on the slide shows a topology without redundancy. S1 has one way to get to S2 and another way to get to S3. The Media Access Control MAC address table shows that S1 reaches MAC A1 via interface F05 and MAC A3 via interface F04. It is represented in the topology as well. Take some time to study the MAC address table and topology. Let us discuss the topology in detail in the following slide. Let us add a link between S2 and S3. Now S1 has two ways to get to S1 and two ways to get to S2. Due to these multiple paths available in different directions, many number of MAC addresses are used and stored, which leads to redundancy. As traffic is received by S1, it adds the MAC addresses and corresponding incoming ports to the MAC address table. Take some time to study the change in topology. Let us continue this in the next slide. S1 receives a frame from S2 with the MAC address of S2. This information is added to MAC address table. S1 can reach MAC A1 via interface F05. Let us continue filling the MAC address table in the next slide. The MAC address table is filled. S1 receives a frame from S3. S3 has received this frame from S2, so the MAC address in the frame is that of S2. This information is added to MAC address table. The entry says that a frame with a destination address of MAC A1 should be sent to interface F04. However, the first entry tells the switch to send any frames with destination address MAC A1 out interface F05. We cannot have the frames sent out to different interfaces. Let us continue our discussion on switching problems in the next slide. The MAC address table for S1 now has two entries for MAC address 00.00.00.00.A1, one with outgoing interface F04 and the other with outgoing interface F05. As S1 continues to receive frames, S1 will also have two different exit interfaces for MAC A3. The MAC address tables for the other two switches, S2 and S3, will also have two entries for each MAC address. The complete MAC address table for S2 shows two exit interfaces for MAC A2 and MAC A3. Similarly, the complete MAC address table for S3 shows two exit interfaces for MAC A1 and MAC A2. Take some time to read the MAC address tables. What happens when S1 does a MAC address table lookup for MAC address A3? Let us discuss this in the next slide. Following points cover the reasons for switching loop occurrence. S1 sends a frame with destination MAC address 00.00.00.00.A3. S1 looks up the outgoing interface in the MAC address table. Due to MAC table aging, it finds F05 interface. When the frame is received by S2, its MAC address lookup finds F06 as the outgoing interface. The frame is sent back and forth between S1 and S2, consuming CPU processing as well as bandwidth on the link. The frame may never reach S3. This is how a switching loop is created. You can see this leads to the problems caused by redundancy. Broadcast storms happen because of the explosive traffic on the networks due to the duplicate frames and switching loops. There is MAC table instability because the switches do not know which outgoing interface to use for frame forwarding. The solution to these problems is the Spanning Tree Protocol, STP. Let us discuss STP in the next slide.